the purpose of this workshop is basically to give you some context on how to actually get started with mud and how to build on-chain apps with mud. And we try to keep it as simple as possible for this workshop, and then there's another workshop following after this one where it's going to be a little bit more advanced and we're extending an actual existing game. For this workshop, there's only 4 very simple steps, which is we're going to create new tables, new systems. I'm going to explain the state sync, and then I'm going to explain namespaces. But I'm not just going to give you the theory about it, but rather the idea is I give you just enough theory so that we then can apply that theory directly in practice and can build an actual game. The game itself is going to be extremely simple. Again, it's going to be the thing you see here on the right side, but it should be enough to basically get you started and experiment with it, and then you can deploy it yourself and make something out of it. All right, I'm just going to get started. If you want to follow along, it's fine. You can also either you can just follow me, like look at my code, watch me coding, but you can also follow along, and it should be simple enough steps that you can actually keep up the pace. Normally, when you would start a new mud project, you would use this early upper command here. Don't do that now. I don't know why I put it here. Actually do this one instead, because we have set up a GitHub repository specifically for this workshop just to remove some of the setup that doesn't add anything to the workshop, like setting up tailwinds, setting up one of the components. So yeah, if you want to follow along, you can go to, you can just git clone this repository basically. Git clone lattice, I guess you have to put the actual URL here. This is just, yeah. If you're familiar with Git, you should know how to get to this repository. We also have a couple of teaching assistants over here, so if you have trouble with any step or with the initial setup or anything, you can just raise your hand or maybe shout something. I don't mind people speaking during the workshop as well. Don't have to be quiet. So yeah, just let us know. I think there was somebody raising their hand there. Is that for a setup question or? Okay, I can't hear you, but maybe one of these 3 guys can help you.
Also clarify github.com/.
Yes, yeah, exactly. So basically this command doesn't, you can't just use this command directly. What you have to do is git clone and then https github.com/lattice/20minutesadventure. That's the GitHub repository. And then once you have that, I'm just going to do it actually live here, so you can see what this is about. Okay, I'm just going to go. Oops. Okay. Also, is this large enough, or should I zoom in more? More? Okay. Okay. So okay, what you have to do is git clone, and then this. So git clone https github.com/latticexyz/20minutesadventure, and that should give you the initial setup. All right, I'm gonna dive in with the setup I have here. This is exactly the same you get when you clone the repository, and this is basically the final state that we will get to in this workshop. So if you do git log, you see a couple of. Let me zoom out a tiny bit. You see basically all the steps that we're going to take. It's not that many steps. And for the purpose for now, for the workshop, I'm going to jump back to the branch called start. There's basically different checkpoints in between. That we can jump to, that you can jump to if you have any problems, get stuck anywhere. You can just jump to any of these other branches or commits on the main branch. And for the purpose of the start of this workshop, I'm going to go to the start branch. All right. And then the first thing we have to do with any mud project that you start setting up is we run pnpm dev. Actually, one more thing about the setup. In here, you see 2 folders. There's one grassland and there's one candy world. The candy world one will become relevant later. We can just ignore it for now. For now, we're just going to work in grassland. And then later, we're going to extend our first world and build another world, basically acting as a new third-party developer. And we're going to extend our first world. And that's when candy world becomes relevant. But for now, we can just go to grassland. and then run, let me do it over here, and then run pnpm dev in there, and that should spin up the development server. So we have our local chain running, we have our contracts, like our deploy runner running, and we have a client running that's at port 3000. Say it again? Oh, did that fail? Okay, yes, I do need to install first. Especially you do need to install first because you didn't already. And if you don't have pnpm, you have to install pnpm, is what my teaching assistant tells me. Oops, that's not what I wanted to do. Okay, so to get pnpm, what you do is npm install dash, what is it, dash global, dash g pnpm. That's the only thing you need. Okay, so now that I ran install, let me try this again. Let me make sure there's nothing running here. Yeah. Oh, what's happening here? Okay, this is unfortunate, but it's actually expected because we didn't do anything yet, and I removed all the default tables. This is expecting the index file that's generated when you do code gen to be there. This wouldn't happen if you start a project from scratch, but for the purpose of the start commit, I actually removed everything, and so this wouldn't work yet. All right, but that is okay. What we can do, oops. What I'm just going to do real quick is jump to the main branch, to the latest state, and show you, I just want to show you the state, like the developer dashboard and everything. So I will do this. Then just to make sure, I will pnpm install again. Everything should be already set up. And then I do pnpm dev again. This should hopefully work. So again, our chain is running in the background. We have our dev script running now. And now that it finds the index file, because we actually have something now, we see the deploy succeeding, and our client should be live at this URL. So let's look at the client real quick. So this is essentially the final state that we will get to later. What you see here is the game board, and we can basically spawn our player and move around. And then what I actually want to show you here on the right side are the developer tools that we have. So on here you see the chain that you're connected to, the current block number, we're connected to the RPC, and we also see the world address, and you also see your burner wallet address that was spun up for you when when you first opened this browser, basically. Okay, I don't want to show too much here yet because we're going to implement this. But before we start implementing, I want to show you the first piece of theory, which is tables. And tables is what tables is what mud uses to represent its state. And the reason why we use tables and just not regular Solidity storage is because we want to enable automatic indexing, meaning we have an indexer running that automatically synchronizes the entire on-chain state to a client without having to write any custom indexers, any custom integrations or anything like that. With regular Solidity, though, you have basically an arbitrary, like you can define arbitrary complex storage schemas. And in order to map that to a relational database, what we want to do, we have to basically restrict you slightly in what state you can represent on-chain, and that is state that can be one-to-one mapped to a relational database. And then in the next step, we can sync that to that relational database and give you the full power of SQL directly through that. So again, the basic unit of state is a table. As an example here, we have our position table, and then we have keys and we have values. The key can either be one key or it can be a composite key of multiple keys as well. And then in this case, for example, we have 3 rows in our table with 3 entities, 1, 2, 3, and then the value of those would be X and Y, and each of those have some value. And then on the contract side, we basically have one storage contract, which is the store contract, and that contains a lot of tables. And then later we're going to talk about access control and how that actually works. So we can have multiple tables in our store. And for those of you who already know Solidity, it might make sense, or maybe it makes it a little bit clearer to think about it like as a mapping, essentially. So essentially all the storage in mud is stored in something like a mapping like a nested mapping, basically, that goes from the type of table that you're interacting with to the keys, and in this case we just have one key. If we had multiple keys, it would be an even further nested mapping. And then the value is the thing that's actually stored in the storage slot. Okay, so that is enough theory for now. So we can jump back into our code, and I'm gonna quit this again because we are on the last branch, but I actually want to go to the start. And then I will run pnpm.dev again. This most likely will fail again, but it's okay because we're going to jump into code right now and do the thing that fixes it, essentially. Oops. So what I have here is just the grassland, so just the first project we're going to work on here. And I'm not going to talk about any of this yet. Let's close all. And the first thing we're going to have a look at is in the contracts directory, so packages contracts, we find our mud config. And that is where we basically define our data schema. And that is the source of truth, essentially. And so the first thing we want to do here is we want to define a table with which we can store the position of our players. And so that is what I'm going to do, is I'm going to just define a table here. And I'm going to call it position. And then we need to give our table a key, and we need to give our table value types. And so for the key, I will put key schema. And what I actually want to store in here is for each player, which should be represented by an address, I want to store their position. So the key in this case would be the player, and the type of that would be an address. And then the next thing we need is the value schema. Again, I want to store the position of the players, so I'm going to represent that with a coordinate x, and that is a UN32. Reason why it's UN32 and not a bigger number is because everything up until UN32 can be represented as a normal number in JavaScript. If you want to have something bigger than that, that's possible too, but then it's going to be a big number, and it's just going to make everything else slightly more painful. So we're going with UN32 for now. And then we save that, and if everything went right, then we should now, now that we saved that, the dev runner that was running in the background automatically generated a file for us, which we now can use to interact with that new table in that new store. All this table library does, we can have a look at it, all it basically does is it interacts with the lower level, which is a good name. Yeah, it interacts with the lower level store library and store contract that I talked about earlier, but it encodes it when you want to write to the storage, and it decodes it when you want to get the value back. And the reason for that is basically just limitations in Solidity that don't allow you to have generic types. So we work around it with this library that is generated for you around the table you want to interact with. And then here we see the file that was the reason why earlier the dev script was failing, is we generate one index file for you that basically exports all of your tables, and then we can use that to import it later more easily. But if that's missing, then the deploy will fail. Okay, so if we go back to the contract script, the dev runner here is now that we created that file and now that table exists, the deploy was actually successful. And now every time we're going to add a new system or a new table, it's going to use that same world address. So it's going to basically upgrade our existing world while we're developing here. Okay, so that's how we create a table. Now let me quickly go back to our dev tools here, and we can see now, oh actually, okay, we can't see a log yet. We can already see a table here, but it doesn't have any like rows yet because we didn't set anything yet. And so just for demonstration purposes, I'm going to go into the post deploy script, which is a Solidity script, Forge script that runs after the initial deploy went through. It just runs once. It wouldn't run again when we upgrade, meaning I have to restart the deployer in a second. But what we can do here is basically run arbitrary logic once for the initial setup for our world. And what I want to do here is I just want to set a value in the position table once so that you can see how it works and how it's automatically synced to the client. So I will import the position table from our CodeGen directory, which is in source, CodeGen, I think, and then index.sol. We could also directly import the table library, but index.sol just makes it slightly more convenient. And then we can use the table library by saying position.set, and then we want to set, so what we set here is the position data, and the first thing we need is the key. In this case, it's an address, and I'm just, again, for demonstration purposes, just going to use address 0, and then we're going to set some position for address 0. And that's how you interact with table libraries in mud. And now we can go back to our dev runner. Real quick, quit this one and restart it in order to have the dev deploy, the post deploy script running so that we can see the table value updating. So I'm just going to quit that real quick by pressing Q and then, oh no, I don't want to quit the entire thing. I'm pressing R, I think. Yes, R restarts just this process. And now we see the deploy running again, and now here you see the forge deploy, the post deploy script running, and now setting our value. And now if we go back to our client, we see in our tables, we should see, we see one row, the player position, the player address 0 is now at position 1 and 1. And so that is basically the first, this seems very simple now, but that was the first major thing we wanted to solve when we built mud. We wanted to just define our contracts and define a data schema we want to use, and then have that automatically sync to the client without writing any indexer or any custom logic anywhere there. Okay, now you know about tables. I think the next step would be to teach you about systems. So I'm going to go back to the slides real quick and go to our second theory part about systems. So while tables are essentially the state part of the application, systems are the logic part. And the reason why those are separated is because we want to make it really easy to upgrade systems for users. So systems don't contain any state. They just read and write from the state that is contained in the store contract. And when you have your mud app, which is your world contract, you can register new system to extend the functionality of that world. And then when a user wants to call one of those functions, they call the world contract, which then routes the call to the system contract, which then reads and writes from the tables. And then every time a table is updated, that emits an event. So that is kind of the life cycle of an event. Yeah, I think that's already enough theory around here, so we can jump back into practice, and I will show you how to create a system that then modifies our position table here. So what I will do next is go into our systems folder, still in contracts, source systems. There's already one system that I will quickly copy just to have some boilerplate here, just the imports. I'm going to rename that to move system. Because what I want to do here is I want to create a system that allows that players can call to, well, change their position, to move around the map. So I'm just going to call this move system. Everything that is called anything with system in the end is automatically picked up by the deployer as a system and automatically registered in our world. So we don't need any other configuration there. You can also exclude specific files if you don't want that, but by default, that's how it works. And then we want to create one new function here, which is the move function. And we want to have two parameters, x and y, and then we want to basically set the position for whoever called that function. So I want to have a UN32, because that's our coordinate system, UN32y. And then what I want to do is I want to set the position. So again, I need to import the position table from our index.sol file. That should be codegen/index.sol. And then in here, for now, I'm just not going to do any checks at all. We're just going to set the position of the message sender. And in this case, I will tell you more about this in a second, but in this case we can't use message.sender, but we have to use the message sender function that is implemented by the system. All right. The reason for, oh, okay, actually looks like we have to, oh yeah, okay, looks like we have to use the position data struct here. This is a config option in the mud config. You can either configure it as accepting regular arguments, or you can configure it to accept. Oh yeah, okay, sorry. Actually, okay, no worries. This was not the thing that it was complaining about. I just tried to call the function right away. But what I actually have to do, this is a library, and so I have to call the .set function to set the value. You can also configure it in a way that lets you basically pass in the struct instead of the individual arguments, in case you have too many arguments, so that you would get an stack overflow error if you have two, I think more than 12 columns in your table. Okay, so for now, what we just want to do is set the position table. And now the reason why I have to use the _message sender function here instead of using message.sender is because this system, this contract, is registered in the world. But then when a user calls the function, the user actually calls the world. And then the world contract calls that system, and then the system calls back to the world in order to read and write. The reason it is like that is because we don't restrict who can register systems in the world. Actually, anybody can register a new system in an existing world. And because of that, we can't use delegate call, because then the system would just have full permission over the entire world. Whereas if the world contract calls the system, then the world can basically manage access control for who can then read and write from which table. Yeah, that should be all. And so basically message sender here is the original sender who called the world function, and not the, if I would use message.sender here, that would be the world contract who is actually calling my system right now. Okay, so this is our very simple system. Now let me update the post-deploy script to show you how to call that system. Normally you would most likely never call the table libraries directly from your post-deploy script or somewhere else. Usually you just want to do it via the system that can basically implement the restrictions you want to have on your systems, kind of like the physics or the game mechanics of your game. So what we want to do here is we want to call that new system that we just created on the world contract, which is the main contract of our app. And so what I will have to do here is we have access to the world address here, but I will have to cast it into the world, which is the type of our world. And then on here, I should have access to, it is world address. And then on here, I should have access to the new function that we just created, which is the move system function. But because this is we're basically acting as a third-party developer right now. We don't have any special permissions in the world, and so I have to call this with the prefix function that corresponds to the namespace that we're in, and the system name, and then the function name, and that should be grassland_move system._move. That should be the function. I will confirm in a second if that's actually the function name. Oh yeah, okay, seems to have worked. So the reason why this is Grassland is because in our mud config, if we go back here, we have set a namespace that is called Grassland. And then in our, the second thing here is the name of our system, which is the move system. And then the third thing here is the actual function within that system. And again, the reason why we do that is because anybody can register new things in that world. And so to avoid naming collisions, it's all namespaced under your namespace. And then this function, again, takes the exact same arguments as our move system. So it's a uint32 and a uint32 x and y. And so if we want to move to, let's say, position 2, then that should hopefully work. And now we have to, again, restart our contracts because, again, post-deploy script only runs on the initial deploy, not on the upgrades. So I'm going to restart this real quick. And then we should see, hopefully, a player on position 2, which is now not address 0 anymore, but whatever the address of the deployer was, because that's the deployer is who sends the transactions in the post-deploy script. And so if we go back here, we can't actually see it on the map anymore because we haven't implemented the map yet. But what we can do is go to the tables tab here and inspect the values of our table. And here we can see, okay, it's not the address 0 anymore, so I'm assuming this is the deployer address, and then the value is 2 and 2, which is what we just set there. Okay, so that is very basic. So yeah, essentially we have we have a table now. We have a system now that modifies that table, but we don't have anything in our game yet that could visualize that. So the third piece of theory, and we're already at step 3, is the state sync. I briefly mentioned that before already, but essentially the way it works is your client is sending a transaction to the blockchain. That transaction goes to the world contract, which is the central entry point of that app, and then the world contract routes it to the correct system, which then reads and writes from tables. And then as we read and write, actually only as we write to tables, that emits an event, which then is picked up by the default indexing sync stack. And so that's what's happening here. And then that sync stack is basically replicating the entire state that you have in your world by default to your client state. And so you have a local representation of the state, which is why we can use the dev tools to inspect the state that is happening on chain. If your world is getting big enough, you can also restrict what is actually synced and have more advanced filters. But for the purpose of this workshop, we just want to have everything. Okay, so that should be, again, enough theory for now, so let's jump right back into it. We've only been working with contracts so far, and so now what I want to do is go into the client and show you how to access that state that we have there in the client. And so I will go into app.tsx. This is a very simple React setup because we didn't want to, we didn't want to have you learn any new concepts. If you don't know React, then maybe that's a new concept, but we try to keep it as close to traditional web development as possible. And so we just use React here, and we have a component that we implemented before already, just to not, drag this out too long. It's the game map basically. So I'm just going to quickly import the game map that we prepared, and it's just a very simple green square which we can use to render our players. And that should be here. And then I can render that here. Game map. I think I have to give it a width and a height. So let's just make it 16 by 16 for now. This is only client side, by the way. On the contracts, the map is not infinite, but as big as it fits in UN32. But on the client, we're just interested in 16 by 16 for now. And that's all for now. So let's have a look at that. Beautiful. It doesn't show any players yet, though. So next step is accessing the data from our client store and then rendering that on the React front end. So the first thing I will do is get stuff from our useMud hook, which is essentially just giving us access on the context on a bunch of useful things. And on here I should have I think it's called useStore. Is it called useStore? Is it in network? Network. Okay. Network. useStore. Okay. So this hook should then give us access to the entire store of our app. So everything that was synced already from the contracts to the clients. And on here, what I'm actually interested in is the data of the positions of the players. So what I want to do is create a variable that is positions, and then I'm going to use the useStore hook to access my store. And then on here we can basically do whatever we want, and whatever, like when the thing we return here changes, then our client will also automatically update. That's just default React, nothing much specific here. What I need here is I want to get entries of the position table. So actually, let me call this tiles, because this is what we actually later want to pass to the game map. And then what my positions are is I can get from the store. There should be a method that's, I think, get records. So just want to get all the position records. And then the syntax of this is the first thing I want to pass in here is the table that we want to pass, that we want to load from. And I get all my tables from, I think, also here. Yes, so tables has access to all the tables that we have defined in our mud config here. And then I can use tables.position to load all the records from my position table. That is in here now. Then what this one expects, though, is the tiles, and what a tile is, we can actually look real quick, what a tile is just X, Y, and then an emoji to render the player. Okay, so how do we get from our positions to the tiles we want to have? It should be as simple as this one returns an object with the ID of the row, so you can have a O of 1 lookup if you already if you already know what you're looking for. In our case, we're interested in all the records. I'm just going to do a object.values on top of this, and then from there we should be able to, let's see, to map over it to basically reformat the state in a way that makes sense for our rendering for our component here. I'm going to do positions.map, and then this each entry in this array is one record. Oops, record. And then what we want to return is instead an object that has three properties. First one is X, and that is we should get that from record dot. So X is part of the value, so we get that from X record.value.X, and then the same with Y. And then finally we want to show an emoji, and for now I'm just going to hardcode this as an experimental user. Okay, so now we have that, and this tiles array is now, this tiles variable is now an array of all of the tiles, X, Y, and emoji properties that we've grabbed from our state in here. And now I should be able to give that here as our tiles. And now we should hopefully see one player. So this is the player that we defined earlier in our post-deploy script. So there's no actual human player who can play the game yet. So that's the next thing we're going to do, is how do we write to the contract. Basically, right now we have the read part on the client. We can read from our contract state and visualize that. But the next thing we want to do is write to our contract. So what I'm going to do here is go into the system calls, create system calls function. This is essentially just a helper to make it easier to organize your code in a way that makes sense. You could technically also directly call the world contract here, but I'm just going to do it here, because later that will be useful. So what we get here on the input for our create system calls, it should be one world contract, yes. And then what I want to do is create a new function that we then can use on the client to call our world contract, and maybe do some additional logic if we have to. So for now, it's just one move function. I'm also going to here accept two properties, which two params, which is the X being a number, oops, not like this, number, and then Y also being a number. And then in there, this is an async function because we want to call our chain and then wait for it. And then what we want to do here is we call our world contract. And this is just a plain VM object. So if you're familiar with VM as a library for Ethereum development, that's just exactly what this is. And then on here, we get access to world contract.write. And now we should have hopefully our, grassland move system move function right there. And then what we have to pass in here is an array of the arguments. That's, again, just VM's interface. And now we can call our contract in here. And then what we also want to do in here, we want to wait for this transaction to actually succeed. We don't actually need it for this demo, but it's in general a good practice to have a method that you can await for if you need the transaction to be actually included in a block instead of just sending off the transaction to the mempool. So we will wait here. I think this is also here. Wait for transaction. So I'm just gonna wait for transaction here. TX also is a promise, so this I will also have to await this. Now this should be our transaction hash, and then we can wait for our transaction hash here. And now this is not happy. Oh yeah, okay, it's happy. Now we have a function that we can call to call our world contracts move system, and then I will just return that here. And now that we've defined this here, this is kind of like a little conventional file structure where you can define these things, and then you will have access to it on your mud context here. I believe that should be here. Yes, system calls, and then on here we should have a move function. And so for now, again, keeping it very simple, we just want to be able to click any tile on the map, and then that should trigger a function call to the world contract. So what I will do here, this is also, again, prepared here in this component. We have the ability to click on a tile, and then we get a callback with the position of the tile. And so what I just want to do here is literally it has the same interface. This one also gives you X and Y, the callback, and then I just want to call the move function. Okay, so that should be enough. The functionality on the contracts was already hooked up before, and so we should be able to now click somewhere here, and yes, have a transaction going through, and now we have a new player here, and we can move around the map. One interesting thing here, again, in the DevTools on the right side, is you can see all of the transactions that are being sent out as I click here on the map, and then you can inspect them, get more information about it. You can see all the store events that were emitted as part of this transaction, and if our transaction would return something, you would also see that here. And even more importantly, if the transaction would fail, this would allow you to debug why it would fail. Okay, so these are actually all the base physics we want in our grassland world. So we have a position, and we're able to move around. That's all we need for now. Now what I want to show you is how somebody else, a third-party developer, could come in and extend this world with their own new physics and maybe build a game on top of this. And to do that, first of all, what I will show you is just as a little proof. We have our environment variable in the contracts, which includes the private key of our deployer. So the deployer is who, the initial deployer of the world is who owns the world, and has basically root access to the world. So remember 0xAC, and then we will switch to the new contracts now, the new project that I briefly teased earlier, which is the Candy World one. And we're gonna open that here. I will actually close this one because we shouldn't need it anymore, and then it's less confusing. So we're going to open the Candy World project, which is, if you're following along, is basically one level above the grassland project. And then, it's sibling directories essentially. Let me also close all of these. 15 minutes. All right. Ooh. Really? That went fast. Okay, so just real quick, I will show you the environment variable file here, and just to show you, this is a different private key, so this person doesn't have any root permission to the world. Okay, so what I'm going to do here is hopefully speed up a little bit. We have our base world still running, and now what I'm going to do is go into this new thing, and I will just deploy, so in our new project, which is the extension of the base world, I can also run pnpm-dev now. Oh, actually, there's one step that we need to connect the new client to the previous world, which is we don't want to, by default, whenever you run deploy, you just deploy a new world, but we want to set it up in a way that the new code deploys to the old world. And because we're kind of running out of time, I'm going to check out the branch for that. So let me just quickly, oops. Okay, so I'm going to go back to main. Then I'm going to quickly check what the thing is, and we want to go to Candy World Start. So again, if you're following along, Candy World Start is the branch we want to go to. Also, let me quickly kill this friend. Okay. Okay, so now we're on Candy World Start, which includes exactly the same state as what we just built together, and then also that small connection between the new client and the new deploy script with the old world. So now I should be able to, again, this is still grassland, so I'm just going to spin up the previous world that we had. Nothing changed here, just quickly confirming it works. So we're deploying the world. and then running our post deploy script. So we have a new world deployed to 0x6E94. And then I can now go to our new project. So we're now a new developer, and I can go to my Candy World project and then run pnpm dev on here, which now we can actually follow along what happens here. Oops, okay. Yes, so what happens here now is that, oops, okay. Oh yeah, same issue as before. We didn't add anything to our current new code base yet, so we don't have an index that's all yet. But what it tried to do was run everything we have set up right now to our new world that was found somewhere. Okay, can't find the log, doesn't matter. You have to believe me that this is the world that we have set up before. I'm gonna jump right into code because I think, 12 minutes left. Let's see if we can speed code this. We're now in Candy World. What we want to do in Candy World is first of all create 2 more tables because we want to extend the previous world. And so we want to basically have an additional layer of reality on top of the previous world. So as before, I'm gonna go back to my mud config. And we don't have any tables yet, but what I want to do here is create a candy position table. And then, as before, we need a key schema. The key schema in this case is I just want to basically store a Boolean flag whether at a certain coordinate there is candy or there's no candy. So our key in this case now is x and y, same coordinates as before. And then our value schema is just a Boolean flag whether it has candy or not. So has candy is a bool. Okay, so we save this. This should hopefully create our tables now. So if we check in our contracts, source, code gen, and we don't have it yet probably because, oh yeah, right. In this case, I'm not running the dev runner for the contracts that keeps redeploying, but I'm just running the normal deploy script. So I basically have to rerun this manually with R to redeploy. The reason for that is because I actually want to, as part of the workshop, I wanted to do some stuff in the post deploy script and then redo that over and over because we want to set the candy in the world. Now you see the post deploy script worked successfully, and now you can also see the world address here. This is the same world as we have running in the other tab. And also this is running a new client, which is on the post 3001. And so we can real quick go there, open it up here. I think, let's just open it here. So this is 3001, looks exactly as before, but in addition we now have another table, which is the Candy World position table. Again, we don't have any values in here yet because we didn't set anything yet. So let's jump back to our post deploy script and write to the candy table so that we can then render that on the client. So I'm again importing the table library from our source code gen index, that's all. And then I'm going to set a couple candies somewhere on the map so we can collect them later. So I'm just going to say, let's say 1, 2, so this is the coordinate, and then true is yes, there's candy in this position. And let's just do a couple more. Okay, so we have 3 candy on our map now. They're not rendered yet because we didn't set up anything yet. But before we're rendering them, let me just quickly also write the system because we have 9 minutes left, so we'll run through this real quick. All of these concepts, though, you already know, so this should feel kind of similar to what we did before, just that this is a new project that is extending an existing world. So we're creating a new system. This system should be the collect system because we want to be able to collect our candy from the map. And so we do that here. And then we have one function that's collect, and we want to. So now it gets interesting. We want to interact with the base physics of our world. Otherwise, this is just almost like a different app. So what I want to do here is I want to first import the position table because I only want to allow players to collect candy on their actual position in the base physics. So I'm going to import the position table from our original world, which one of the things I set up earlier when we skipped ahead to this state is there's now like the previous project is installed as a dependency on this project, so that we can now import this from Grassland source codegen index.sol. So this should point to to our previous project at Grassland. And then I also need the the candy position table, because obviously we can only collect candy if there is candy, and then also we want to remove the candy from that position. So we will import the position table here, the candy position table from codegen index, yes. And then we will implement the physics of our game. So again, 2 parameters. We want to be able to pick up candy from a certain position. So we need to know which position it is. Let's say x and 32y. And then the first thing we need to require here is that the player is actually at that position. And for that we can get the, we need the position table, and then we get the position of the current, of whoever calls that function. And I believe this is returning now our position data thing that I talked about earlier. So I will have to import that as well. Again, this is something you can configure in your mud config, but by default I believe it's this one. So this one will be the player position. And then we want the player position to be wherever we are right now. So we want to say player position dot x equals x, and player position dot y equals y. Okay. And if that's not the case, then we throw an error. Okay. And then once we did that, the second thing we have to require is, of course, that there is candy at this position. And so we do another check here, is require candy position, and now we can basically just say .get, because this one only returns one value, which is a Boolean, so we just get the x and y. We could also, there's also another function on this method, which is get has candy, because you can basically get each individual field directly. And then if that's the case, if that's not the case, then we also revert. No candy here. Okay. Why is this unhappy? Oh, forgot a semicolon. And now finally what we want to do is the player collected the candy, so we want to remove the candy from this candy table. So we just do candy position dot delete record at x and y. And now there should not be candy anymore. Okay, this is a scoped down version. Normally I would also create a candy balance table and then count the amount of candy we have. Since we have 4 minutes left, I'm not going to do that. But what I will do is jump back into our app.tsx. Real quick, render also the position of candy. So let's see, candy. We do exactly the same thing as before. We get our candy positions from our store. So we can do object.values store.get records. Now the table is candy position. Is this happy? Oh, get records. Get record would allow you to get one record out of our store, but we're interested in all of them. And then get records candy position gives us all of them. And now we can, again, we have to map that to the type we actually expect. So let me map that to record x. And now, in this case, the x and y is part of the key, which means on the chain we couldn't get all of the records of the candy position and then access the key, because that's how it works on chain. But because we emit the key also as an event, the indexer can actually index the key as well, and we have access to the key here as well. And then same for the y. Good thing is the workshop after this is my teammate, so I think maybe we can go 2 minutes over without him being too mad at me. Okay, and the emoji that we want to render here is a candy emoji. Okay, hopefully this should be enough. And then what we want to return is basically the combination of both. So what we have here is the players. Over there we have the candies, and then what we want to return is just both of them. Okay, and now this should hopefully be happy, yes. And now I think we did we set anything yet? All right, we did set something in our post-deploy script, but we did not rerun the contracts yet, I believe. So I'm gonna rerun this. Oops. Rerun the post-deploy script so that we have data set in our candy table, which then can be rendered to the client. Okay, so this again ran the same thing on the existing world. So we can go back here and we see 3 candies. And now as the final step here, we want to also pick up the candy so that you can see it actually works, and we have a full extended world with our base physics and the extended physics. So I'm going to go back to system calls, what we did before, and I'm just going to, again for speed reasons, I'm just going to add it to the same move function, meaning every time we move, we're also going to try to pick up candy. So I'm just going to do world contract .write and now it's the different namespace, so it's Candyland collect, Candy World collect system collect, but then the parameters are the same. Okay, this worked, and then we want to await basically both transactions. I'm just going to do it for this, like this for now. Okay, so now what should happen is we are able to move, and we are actually waiting. We have to wait for this transaction to be done. Reason for that is because the second transaction, the Candy World transaction, expects our player position to be at that position, otherwise it's going to revert. So if we set it up like this one should wait for the first transaction to be done, and then wait for and then only then execute the second transaction. And now if everything went right, then we can now here in our world move around. We're going to get one revert here because I just moved to a position where there is no candy, but my client still tried to collect the candy. So this one reverted with, no candy here. So great to debug. But now if we go to one of them that has candy, I can move there. We shouldn't, now there's another Candy World collect transaction that went through successfully. And if I walk around here, there's no more candy at these positions because we picked all of it up. That's it for the workshop. We have a built-out version of this game, which you can have a look at if you check out the final branch. And then we also deployed this already to Redstone, which is the new testnet that Lattice is running. So in theory, we don't have time to actually try it out, but in theory, you should be able to check out the final branch, then spin up a local client, and then that should already connect, hopefully, to the Redstone deployment, and then you can actually play against each other. But yeah, that's it for now. Thank you so much.